In this short video, we're going to look at the transformations of exponential functions. So I want to look at y equals a times 2 raised to the bx plus c plus d. So the exponential parent graph that I'm going to talk about is y equals 2 to the x. And I'm going to figure out what happens when I change the values of a, b, c, and d to my parent graph. So let's go over here to look at my basic graph. Right now in blue I have graphed 1 times 2 to the 1x. So this is just 2 to the x. And that is my blue graph here, and underneath it is a red graph that will be my parent graph that will never move. So let's take a look at my parent graph. Remember, it's y equals 2 to the x. When x is 0, 2 to the 0 is 1. 2 to the 1 is 2. 2 raised to the second power, 2 squared is 4. 2 raised to the third power is 8. So I get my basic increasing exponential graph. And also notice when we graph an exponential function, we must graph as a dotted line the horizontal asymptote along here, which in the parent graph is the x-axis, otherwise known as the equation y equals 0. So now I want to look at what happens when I change different values over here. So what happens when I change my value of a? For this class, the only value of a you need to know is a equals 1 or negative 1. In the parent graph, a equals 1. So what's going to happen when a equals negative 1? Remember from our previous work with algebraic functions, when I multiply outside by a negative 1, it is a vertical reflection. Let's see in this case, does this look like a vertical reflection? Yes. When a equals negative 1, so my graph now is y equals negative 2 to the x. Notice the points that were 1 unit above are 1 unit below, 2 units above, 2 units below, 4 units above, 4 units below. So we got a vertical reflection in the x-axis. But notice the asymptote that was the x-axis has not moved. So when a is negative 1, over here you can see we get a vertical reflection in the x-axis. So now we want to figure out is what happens when I change the value of d. This number is added or subtracted outside the function. So again, knowing what we know from our previous work, this is going to be a vertical effect. So let's go over here. We're going to take a back to 1. D right now is 0. So what happens when I add a number outside the function? So let's make d 2. So you can see I have 2 raised to the x plus 2. So what happened to my graph? If you look at this point, it moved up 2 units. Did the same happen here? Yes. And here. And notice also that the asymptote, the horizontal asymptote y equals 0, shifted up 2 units. So D shifts the whole graph, including the asymptote, up if D is positive. Or here's my parent graph again. Now let's make D negative. Where does the graph go? If D is negative 4, it shifts the whole graph down 4 units, including the asymptote. So the asymptote that was originally at y equals 0 is now at y equals negative 4. So over here we can see that what does D do? If D is positive, it's going to be a vertical shift up, and if D is negative, we're going to have a vertical shift down. Now we need to look at the effects of B and C. Just like with A, the only values of B that you need to worry about in this class are 1 and negative 1. So let's go back over here. We bring D back to 0. We're back at our parent graph, b equals positive 1. Now I want b to be negative 1, so I'm going to multiply x inside the function by negative 1. And what is this going to do? Well, let's take a look. What happens when b is negative 1? Compare our new graph, the blue one, to our parent graph. It is a horizontal reflection about the y-axis. Points that were on the right and now the same distance on the left. This was 1 unit on the right, 1 unit on the left. Points that were on the y-axis stayed on the y-axis. And notice the horizontal asymptote didn't move because the points over here became points over here. So your horizontal asymptote is still y equals 0. So we can see what happens when b equals negative 1. It's a horizontal reflection in the y-axis. The last thing we need to look at is what happens when the value of c is changed. So let's go back over here and we're going to make b back to 1, so we're back to our parent graph, and now we're going to change the value of c. c is currently 0, so let's see what happens when we make c 1 or 2. Let's say c equals 2. Well, what happened to the points? They moved 2 units to the left. Let's make c even larger. Let's make c equal to 3. Did all the points move 3 units to the left? Yes. And what happened to the asymptote? Well, if I take a point here on the asymptote and move it 3 points to the left, is it still on the same horizontal asymptote, y equals 0? Yes. So when c is positive, I'm going to move the graph to the left, and then just look at what happens when c is negative. So c is negative 2. I moved all the points on my parent graph 2 units to the right. So here we have what happens with c. It's a horizontal shift. If c is positive, it shifts to the left. If c is negative, it shifts to the right. And just like we learned before, we have to do these transformations in the correct order. The important thing to remember is you always horizontally shift first and you vertically shift last.